yesterday we implemented all the functions of PLL. Only one was pending, which was remove a node before the given node. This one, remove before. So remove a node which exists before the given node. So basically, into this, what we need to do, we need to search for the given node, and once we get the given node, then we need to delete a node which is before the given node. Okay. So here into the searching loop, this loop, we are making use of two pointers, a prev pointer and a TMP pointer. So the prev pointer would be pointing to a previous node. So after this, when you come out of this, so since the condition is temp of next not equal to h, that's why we need to check for the data of the last node, because this will not check the data of the last node. This condition will not check the data or compare the data of the last node with the given key value. So that's why we need to have this additional test over here. And if this is not the case, if the last node data is also not equals to the given key value, in that case, uh, we will be moving forward. Okay. So after this, if temp equals to h, and at the same time temp of data equals k. Now, what does it mean that we are giving a first node? So what the user is trying to do, the user is trying to say that delete a node before the first node. Now, since there is no node before the first node, so this condition would be true. That is temp equals to h. So temp is basically pointing to a given node. So temp equals to h means it is pointing out to a first node, and temp of data equals to k, and its data equals to the given key value. So if this is the case, it means that the user want us to delete a node before the first node. Now, since there is no node before the first node, so that's why we are displaying the message no node before the first node. If this is not the case, then we'll go for this condition if temp equals to h and at the same time temp of data not equals to k. Now, what does it mean when we say temp equals to h? It also means that we have checked the entire list and we have not found the given node. So it is something like the given node does not exist. But when it will be valid if temp equals to h and at the same time temp of data not equals to k. Okay. So temp is since it is circular linked list, so we have checked for all the nodes. After checking for all the nodes, we have come back to the first node. That's why temp is pointing to h, and at the same time, its data is not the given key value. So in this case, we can safely say that the given node does not exist. Okay. If this is not the case, if this is not the case, sorry, if this is not the case, and even if this is not the case, it means that uh, we have found the given node. So the given node does exist. Okay. And prev is pointing to a node before the given node. So basically, we want to delete the node which is pointed by prev. I repeat, we want to delete or we have to delete the node which is pointed by prev. Okay. So for that, what we are doing, since we need to delete a node which is pointed by prev, so we need to have an access of a node which is before the prev or which is previous to prev. So when we reach that node, we'll make the next pointer of that node to point to the next point of prev. Okay. So we can take out the prev from the list. So that's why we need this traversing temp equals to h, and then while temp of next not equals to prev, temp equals to temp of next. So this is simply a traversing till you reach a node which is just previous to prev or which is just before prev. So while temp of next not equals to prev, temp equals to temp of next. Okay. Then after that, if temp equals to h, it means that When time would be h? Can anyone tell me when time would be h? When you will come into this if you have found when you are coming at this point, let me tell you, you have found the node which has to be deleted, which is pointed by prev, and then temp is pointing to a node which is before prev. Okay, so I am asking you when this condition would be true, when your temp will become equals to h. It means that which node we need to delete when this is true. First node. Prev is pointing to a node which has to be deleted. Temp is going to point to a node which is which is temp is pointing to a node which is just before prev, just before prev. So if temp equals to h, then which node we are going to delete? Yes, last node. Yes, come on, tell me. Second last node. No, I come to the starting point of the function. What we can see here, here carefully. We are having two pointers, temp, prev, and the condition is while temp of next not equals to h, and at the same time temp of data not equals to k. So basically we are searching for the given key element, and then this loop goes on, and this is an additional check because we are missing the last node because of this condition. Okay, so this if is also having the same two statement which is there into the while loop. So when you come out of this while and if at this point where my cursor is, at this point, temp, if the node exists, if the given node exists, so temp would be pointing to that given node, and prev is pointing to a node which is previous to the given node. And here, what we need to do, delete a node before the given node. So it means that at this point of time, at this point of time, the prev is pointing to a node to be deleted or to be removed. Please try to understand. Prev is pointing to a node to be deleted. Okay. And temp is pointing to a key node. After that, we are putting some check if temp equals to h and at the same time temp equals to k. So this is something like you want to delete a node before the first node. So this is not possible. So we say no, it cannot be done. And temp equals to h and at the same time temp of data not equals to k. So the given node does not exist. So basically, what I can do, it is safe to say this at this point. So at this point, basically my preview pointer, I can safely say that my preview is pointing to a node to be deleted. Okay. Now preview is pointing to a node to be deleted in a list. Now this is a circular linked list, but still it has single pointer in every node, which is pointing to a next node. So to delete any given node, preview is the node to be deleted. We need to reach to a node which is before preview or which is previous to preview. Then only this node can be deleted. Okay. So for that we are having this additional traversing. So time equals to h, and then while temp of next not equals to preview, time equals to temp of next. Okay. So we are traversing so that we can reach to a node which is before preview. Okay. So after this while loop, we are expecting that temp is pointing to a node which is before the preview. The moment I say temp equals to h, after this while loop, let me write it. Temp is pointing to a node before or you can say previous, whatever you want to understand. Before the previous to the node to be deleted. Okay. Now, now again tell me. Now, if temp equals to h, it means what? Which node you want to delete? Yes, you want to delete the second node. Temp is pointing to h, and temp is pointing to a node which is just before, just behind, or just previous to a node to be deleted. And temp is pointing to h, h is pointing to first node. It means that we are going to delete the second node. Okay, or preview is pointing to the second node. Now, if that is the case, that you want to delete a second node, so do I need to do this? Next equals to 0. This setup, which I am doing here, q equals to h, and then while q of next not equals to h, q equals to q of next, and then h equals to h of next, and q equals to q of next. Now this setup is required when you want to delete the first node. Am I right? This setup is required when you want to delete the first node. Why you know? Because this is CLL, circular linked list, and when you are deleting the first node, you need to ensure that the last node pointer is now pointing to the new first node. Okay. So when you delete the first node, the second node is going to become the first node. So your last node next pointer should be pointing to this new first node. Okay. So for that we are making use of this code. Now this should be executed only if you want to delete the first node. And when you want to delete the first node, and my preview is pointing to a node which is to be deleted. So basically this condition is wrong. This is not time equals to h. It should be if preview equals to h. The node to be deleted is the first node. If that is the case. Else, if it is the second node, then temp of next equals to preview of next. Absolutely fine. Then preview of next equals to null, and then free preview. Okay. And here temp equals to h while temp of next preview is the first node. When I say temp equals to h, so while temp of next not equals to uh,
Okay, let's see. I think this should work. It's session 24, and this is the execution of the code. Let me enter few data: 10, 20, and 30. So I got three nodes, and I have modified the display function. And see what I am doing into the display function. There is little modification into the display function so that we can clearly understand that how our the linked list exists into the memory. That generally what happens when we display the list, so we display only the data part. Okay. Now I have modified the display function in such a way that not only the data part should be displayed, but also the next part. And not only the next part should be displayed, but also the address of individual node. Okay. So what we are doing, let me show. Seventh option, display. Now see here carefully. What has been displayed. Please see it. This is the complete display. The first line is circular linked list content, and the last line is size of linked list. Okay. In between this, you have these three important information. Now, the first line is something like a header, address, data, and next. So basically, this is my address column. Okay. This is my data column, and this is my next column. Fine. Data is the data part. Next is the next pointer, and this address is an address of individual node. I repeat, it is an address of individual node. So this is the data of my first node, 10. This is the address of the first node. I repeat, this is the address of a first node. So 275E0, 275E0 hexadecimal value is the address of my first node. And this is the next pointer value of the first node. Now the next pointer is having the address of the second node. The next pointer of the first node is having the address of the second node. So the address of the second node is what? 27600, and then the same value exists over here. And that's why the first node 10 points to the second node 20. Okay. So the address of this node, second node 20, is 27600, and then the same value is into the next pointer of the first node, 27600. Then this is the data of the second node, and this is the next pointer value of the second node, which is the address of the third node, 27620. So 27620 is the address of my third node. The data is 30 of the third node, and then the next pointer of the third node is 275E0. 275E0, which is the address of the first node. Since it is a circular linked list, so the last node should be pointing back to my first node, and so the next pointer of the last node is 275E0, which is the address of my first node, 275E0. Okay. So this way, when we display the content of the list, we get a very clear information that what's happening behind the scene, and how the things are getting changed. Okay. Now, when I do some insertion, before the removing anything, let me insert, and let me go for insert begin. So what I am doing, I am changing the first node, or I am inserting a new node at the beginning of the list. So when I do this, and this is a circular linked list, the next pointer of the last node, that is 30, should be changed over here. So let me go for the second option, insert begin, and let me put up a data as 5. Okay, so it has been inserted. Let me go for the seventh option. So now this is my list, data 5, 10, 20, 30. Now if you see carefully, my first node is 5. Address of the first node is 27640. And the next pointer of the last node is 27640. Okay. Rest of the things are same. Rest of the things in the list are same as earlier. As earlier. Okay. The second node was at address 275E0. the first node earlier. Now it has become the second node, and its address is still same 275E0. Okay. So this is how the list is maintained in the memory, and we are looking for the remove before function. So let me go for the sixth option, remove before, and let us start with the key value which does not exist. So let me give 50. It says the given node does not exist. Fine. Then again remove before, and let me try to remove a node before the first node. Let me check for that condition. My first node value is 5. So I enter the key value 5. And yes, it says me that no node before the first node. And after all this operation, let's check whether the list is still intact or not. Otherwise, since we are playing with all pointers, there can be issue. Okay, so the list is still intact. And then let us go for remove before with some other option. This is my list. And suppose I want to remove a node before 30, before the last node. Okay. So I want to remove 20. I mean to say that. So let us see whether it is done or not. Let us display. Okay. So 20 has been removed properly. And then we have three nodes 5, 10, and 30. Now let us try to remove the first node. When I want to remove the first node, it means that my key value should be the value of the second node. So let me go for the sixth option, remove before, and my key value, let me put 10. And now let us display. Okay, so 5 has been removed, and now we have two nodes into our list, 10 and 30. So our remove before function for CLL is working properly. And if you see the address part, so yes, it is proper. The next of the first node is having a value 27620, which is the address of the second node. Perfect. And then the second node is the last node. So the next part of the second node is having a value 275E0, which is the address of the first node. Okay. So our circular link list is properly working now. All functions are properly working. And I strongly recommend you to make use of this kind of display function where we try to display almost all the information about a list. This one. So I am displaying three things: address, data, and next. This is outside do while, and inside do while, the address format specifier is percentage %x because it's a hexadecimal value. So the first is address, so percentage S X. The second is the data, percentage D. Then third is the next pointer, which is again a address, so percentage X. And then here you can see first I am writing temp for the first percentage X because temp is a pointer which is pointing to a current node. Okay, so I need the address of that current node itself. I am writing TMP. Second is the data part, so I need to write TMP of next, sorry, TMP of data. And then third is the address, which is the next pointer. So I simply need to write TMP of next. That's all. Okay. So TMP, comma TMP of data, comma TMP of next. This will display your entire information. Fine. Any query into this from your side? If no query, then we can shift to next point, next topic. Yes. can wait for a minute here. If you have any query, then please come forward. Any doubt, any query. You need to practice this code, no doubt about it. You need to practice it two times or even three times, even multiple times to understand it. And once you understand it, then it won't be a big deal. You only need to visualize properly that how the pointers would be changed. The entire story is about pointers. How do we handle the pointer? Okay. Linked list is all about pointers. All about pointers. So if you miss out any pointer, if you miss out any link, then you are playing with the list, and then you cannot guarantee whether your list will be intact or not. And there are a few important things which you need to always keep in mind that whenever you are handling any list operation, so you need to always keep in mind that you are first making a link and then breaking a link. I repeat, first make a link and then break a link. Okay. So always remember, first you need to make and then you need to break. If you break a link before making a link, then it will be quite difficult. Okay. I repeat, it will be quite difficult to handle the list. It is always preferred first to have a make and then break. Okay. So you should remember this thumb rule: make, then break. Make, then break. Make, then break. So first you make up a link and then you break a link. And if you practice few times, then it will be done. It's not a big deal. It's not a rocket science. Okay, if there are no queries, then we can jump to our next topic. The next topic is your doubly linked list, the third type of list. And since this is a complete program for the CLL, let me have a copy of this for DL. I can't make it session 25, so I would be writing it session 24 dash 1. And this is my doubly linked list. DLL. So what can be a doubly linked list? Any idea? Yes, what can be a doubly linked list? You know what is singly linked list, you know what is circular linked list, and the third type of list is doubly linked list. So what can be a doubly linked list? Come on, come on, have some guesses. Current node will point to next as well as previous node. Good. Any other student? Yes, this is perfectly written that your current node or any node in fact will be having double pointers or two pointers. So far we have seen that in SLL and CLL, your node consists of two things. One is the data part and one is the link part. Okay, a link part which points to the next node. In case of DLL, your node will be having three things: a data part and a link part to a next node, and again a link part to a previous node. So basically, in DLL, in every node you'll be having two pointers, one pointer pointing to the previous node and one pointer pointing to the next node, apart from the data part. Okay, so for representation point of view, what do we do when we draw the node? So we keep the data at the middle of the node, and then a next pointer on the right hand side pointing to the next node, and a previous pointer on the left hand side to point to the previous node. Okay, so for example, this is my data, and this is the next pointer. This is the next pointer which is pointing to 20. So this data, before data, I will be having one more pointer which is pointing to the previous node, something like this. Okay, so for every node you have two pointers, one is pointing to the next node and one is pointing to the previous node, something like this. Okay, so in a setup you have two pointers in every node, and the next pointer of the last node points to null, and likewise the previous pointer of the first node can point to null. Okay, previous pointer of the first node can point to null, or you can make it to point to h. It's up to us how do we implement. But generally, it points to null, and then the next pointer of the last node points to null. Okay, and then the h pointer always points to the first node or the header. Now, the advantage of doubly linked list over SLL and CLL is that because of these two pointers, it is quite easy to traverse in the list because you can move in two directions. With the help of next pointers, you can move in forward direction, and with the help of previous pointers, you can move into the backward direction. So, if you are at node number 4 and you want to come back to node number 3, so with the help of preview pointer of the fourth node, you can come back to the third node in case of DLL. But the same option is not available for your SLL or your CLL. In SLL or CLL, if you are on node number 4 and you want to go to node number 3, then you need to start the traversing from the first node. There is no option other than this. You need to start the traversing from the first node. But in case of DLL, because of this two-way direction, two-way traversing, you can move in forward direction, you can move in reverse direction. So because of this, you can move in the either direction. So if you are on say node number 99 and you have 100 nodes and you want to come back to node number say 97, so with the help of preview pointers, you can easily come back. So you need only two operations. From node number 99, you need to make use of the preview pointer. You will be coming to node number 98, and from node number 98, with the help of preview pointer, you will be coming to node number 97. But in case of SLL and DLL, while traversing the list, you have reached node number 99, and if you need to come back to node number 97, you need to again start the traversing from the first node. So you need to again traverse all the nodes till 97. Then only you will be reaching to that node number 97 in case of SLL and CLL. But in case of DLL, this traversing is quite easy because you can move in either direction, or you can move in both the directions. You can move in the forward direction, you can move in the backward direction. One link, the next link will take you in the forward direction, and a previous link will take you in the backward direction. Okay, so that is the advantage of doubly linked list. And obviously, when we are making use of doubly linked list, there is an additional pointer in your structure, and accordingly, you need to handle that additional pointer everywhere. That's all. Uh, what I will be doing, I it's better to convert my SLL program into DLL because DLL also have this null pointer. It is not circular DLL. So there I will be making very few changes to transform the SLL program into a DLL program. So let me do that. Session 22 is SLL completed. 22 is also CLL. Session 21. Yes, this is SLL. Session 24 dash 1. Changing it. Okay. Session 21. This is my session 21. This is 24 dash 1. This part is it has been deleted. This is my session 21. Control C, Control V. This is not getting okay. Sigma 24 dash 1. Yes. Now a doubly linked list. What we will be doing into this, the first thing is to change all SLL, find and replace all SLL with my DLL. Replace all. Okay. So then, apart from this next pointer, I will be also having one more pointer of the same type, and let me call this pointer as preview. Okay, so every node is going to have two pointers. One is the next pointer, one is the preview pointer. Apart from the data part, so this is insert at end, and when you are saying p of next equals to null, at the same time, safe programming p of preview also equals to null. And later we can change pointers as required. So if h equals to null, then h equals to p simply let else temp equals to h while temp of next not equals to null, temp equals to temp of next, and then temp of next equals to p. And one more additional statement, since you have got additional pointer, so you will be writing p of prev equals to temp. Okay, so now temp becomes the second last node. So P of P equals to temp, temp of next equals to P, done. Yes, this is fine. So insert at end function is done. Let us see the display function. And the display function. This is my display function. I need only the size. I do not need these two. So I'm commenting it out. And then apart from the basic content of the list, I also want to display additional information which we did for the CLL. So that we can do over here. So let me write in front of you printf uh, on a new line with say two tab spaces. I would be first displaying the address part of my node, and then the way generally we display the DLL, that way I would like to display here. So I would display preview part. I would display the preview part. Okay, and then I would display the data part, and then I would display the next part. That is the next address. Fine. And then here on a new line with two tab spaces, my first is the address. So percentage X, and let me give tab space. And again, it is an address and a preview pointer, so percentage X, and then tab space, and then it's a data part, percentage D, then tab space, then address part, percentage X. Okay. So the first address is the address of my node itself, so TMP, comma. The second address is the previous pointer, so TMP of slave. Then the third part is the data part, TMP of data, and then the fourth part is the next pointer, so TMP of next. Done. Let me say. Let me use tab spaces over here. There may be little issues with the formatting of the data, but that we should understand and take care of. So I think the main function is also changed, and display at end is there, and then sorry, insert at end is there, and then the display function is also there. So let us compile this code. Fine, it is compiled. Let us execute it. So insert at end, I say 10, I insert one more data element 20. Now let us display the list, six option. Okay, so list, linked list content, address, preview, data, and next. Zero is nothing but null. So this is the address of my first node. The preview of first node is null. Data is 10 of the first node, and the next pointer is 9A7600, which should be the address of the second node. And yes, the address of the second node is 9A7600. And then the preview pointer of the second node is 9A75E0, which should be the address of the first node because it is the preview pointer of the second node. So the preview pointer of the second node is 979A75E0, which should be the address of the first node. And yes, it is an address of the first node. And then the data of the second node. And then the second node is the last node. So the next pointer of the second node is null. So the address part is 0. That is the ASCII value. ASCII value of null is 0. That is showing as 0. Okay. So you have seen it was so easy for us. We have added, I think, only one statement into the insert at end of SLL to convert into insert at end for DLL. Okay, so this is our insert at end, and what we did, we added this statement: P of preview equals to temp. Okay, so P of preview equals to temp. Since we have an additional point of view, and for safe programming, here also we did this part. So I can say additional to SLL I can write. You can easily understand it. And here also, this is an additional statement to the function of SLL. That's all. Everything else is same. And then display function is completely same. Only we wanted to display additional data. So that's why we have written this. And the same way you can do for SLL, only the preview pointer will not be there in case of SLL display function. Okay, fine. So we stop here today. If you have any query, so please let me know.